Okay, now we're going to derive the hydrostatic equation. And we're going to consider a coordinate system. And it's going to be a local coordinate system with the z hat, y hat, and x hat, and it's a Cartesian. And it's oriented locally so that the z hat points upward or in the opposite direction of gravity. So gravity is in the minus z hat direction. And now we're going to consider a column fluid. With the surface set at z equals 0. And at depth z, we're going to imagine a little fluid parcel of thickness delta z. So the surface area of that little parcel is delta A is equal to delta x times delta y, where x and y are the lateral dimensions of our little parcel. The volume of that parcel is delta V, and that's equal to delta A times delta Z. And then the mass, small bit of mass, is going to be rho times the volume, and rho is the density. Alright, now we're going to consider a static force balance in the z hat direction or in the vertical. And the fact that it's static means that the acceleration in F equals ma is 0. Otherwise, we wouldn't have a static situation. And if a is 0, then F is 0. And in particular, F dot z hat is 0. Alright, now we're going to consider the individual forces. First, the force of gravity. And remember, the gravity is pointing in the minus z hat direction, downward, so we need a negative. And then there's going to be the force on the top face, and that is also pointing downwards. Right? It's the force of the fluid above the parcel pushing down on the parcel. And so we put a negative sign. And that's the pressure times the area, and it's the pressure at z plus delta z. Remember, the pressure is a force per unit area, so if we multiply the pressure times the area, we get back a force. And then the force on the bottom face, and it acts upward in the same positive z hat direction. So we use a plus sign. Right now, the total force balance in the vertical direction is the force of gravity plus the force on the top face plus the force on the bottom face. All those have to add up to 0 because we're in a static balance. Now making the substitutions, first for gravity, then the force on the top face, then the force on the bottom face. Now we're going to do, as we always do in fluid dynamics, is we're going to divide by delta V. That is, we're going to consider the force per unit volume. So the delta V goes away on the first term, and now we're going to factor out the minus sign and the delta A. So we're left with minus, open parenthesis, pressure at z plus delta z minus pressure at z, right? We factored out the negative sign. And then we're left with delta A divided by delta V, which is simply 1 over delta z. And the second term is a derivative. So if we take the limit as delta z goes to 0, we get the partial derivative with respect to z. And that is the hydrostatic equation.